Now, if you start with a system that is a linear and a quadratic, one of the surest ways to be able to solve it pretty efficiently is to use substitution. Do you see how this is solved for y? Once you have something solved for y, you can plug it back into the y on the other one. And likewise, if you have something solved for x, you can do the same thing. So I could say 3x instead of y. I'm going to say plus 1/2 x minus 3 squared equals 4.5. So all I've done is I've plugged this in for the y in that equation. There's my 3x. Instead of y, I plug in 1/2 times x minus 3 squared. And then I finish up equals 4.5. We keep going here. So it'll give me 3x plus 1/2 of this FOILed out. So if I FOIL out x minus 3 times x minus 3, I get x squared minus 6x plus 9. Again, all equal to 4.5. So I'm going to keep going. Alright, I'm going to distribute the 1/2 in, so I have 3x plus 1/2 x squared minus 3x plus 9/2 or 4.5 equals 4.5. So I'm seeing some stuff here I like. Right? I can see that I can combine these like terms, right? Which gives me 1/2 x squared, the 3x's disappear, plus 4.5 equals 4.5. Subtract 4.5, I get 1/2 x squared equals 0. Multiply by 2, you got x squared equals 0, or x is equal to 0. And it doesn't really matter where you put it in. If I put it in right here, we can plug x into 0 in there. X equals 0. I got 3 times 0 plus y equals 4.5. That gives me y equals 4.5. So I have an ordered pair solution of 0 and 4.5. One solution. Very often you're going to get two with these guys, but this guy, I've only got one. Alright, so let's go through and try one more time. Lots of ways to do this. One way would be to solve this top one for y. If I subtract 3x, I get y equals negative 3x. I circle it. Now this y here turns into negative 3x. So here I go. Negative 3x minus 6 equals negative 3x squared. And all I did is I solved this one for y and plugged the y value, which is equal to negative 3x, into here. I'm going to add 3x squared. I'm going to add 3x squared. And I've got 3x squared minus 3x minus 6 equals 0. I can actually divide both sides by 3. That would change the graph but not the solution. So I got x squared minus x minus 2 equals 0. If you remember how to factor, this becomes kind of easy. You say what multiplies to negative 2 and adds up to negative 1, which would be negative 2 and positive 1 equals 0. We set both terms equal to 0. X minus 2 equals 0. X plus 1 equals 0. If I add 2, I got x equals 2. There's one solution. Subtract 1, x equals negative 1. So this is solving them. You can also plug these back in, right? I plug 2 back into this, right? I get y equals negative 6. And when x equals negative 1, I get y equals 3 for ordered pair solutions of 2, negative 6 and negative 1, 3. Alright. I could have also done that with a quadratic formula, but if you remember how to factor, it's a little bit easier. Notice this guy right here is solved for y. So let's keep going. So I'm going to circle that, and I'm going to plug it in for this y value here. So here I go. I'm going to go 3x, right, minus 2, and instead of this y, I'm going to plug in 1/4 x minus 3 squared, and then I set it equal to 13. So I'm going to work through this. It looks a little tougher this one. So we get 3x minus 2 times 1/4. If you FOILed this out, you would get x squared minus 6x plus 9 equals 13. You know what? We can bring that 1/4 in, so we get 3x minus 2 times 1/4 of x squared minus 1/4 of negative 6 is negative 3/2 when reduced to x. 1/4 of 9 is plus 9/4, all equals to 13. A little tougher, right? Multiply everything in here by negative 2 to bring it in. I could have done that a little bit different, but this times this is negative 1/2 x squared. This times this is positive 3x. This times this is negative 9/2, all equal to 13. Looks like we have two sets of 3x's here. So I can combine those, right? Which gives me negative 1/2 x squared plus 6x minus 9/2 equals 13. I'm going to do something weird here. I'm going to multiply both sides by 2 and get rid of my fractions. I don't know if this makes it easier or harder, but it'll get rid of fractions. So if I multiply by 2, let's do a negative 2. That way my x squared will be positive, right? Multiply the whole thing by negative 2. That gives me positive x squared minus 12x plus 9 equals negative 26. Now I can add 26 to both sides. Once you're this many steps in, it really pays to have someone doing it along with you, because at any point in there I could have made a little mistake. 26 and 9, that's 35 equal to 0. Now, to tell you the truth, this kind of tells me I know there's factors, right? Two things that multiply to positive 35 and add up to negative 12 are negative 7 and negative 5, right? So once I get this far and something like that happens, I'm pretty sure my steps are good. X minus 7 equals 0. Set this equal to 0. X minus 5 equals 0. We got x equals 7 and x equals 5. And really, we can plug those back in. So what's the easiest one to plug in? It's not too bad to plug it in here. So I'm going to take 3x minus 2y equals 13. I'm going to plug in x equals 7, which gives me 3 times 7 minus 2y equals 13, or 21 minus 2y equals 13. I'm going to bring the 13 over here and the 2y to the other side. So if I subtract 13, I get 8 equals 2y and y equals 4. So I've got 7, 4. And then I can say x equals 5, and that gives me 3 times 5 minus 2y equals 13, or 15 minus 2y equals 13. And these answers are really nice. Negative 2y equals negative 2, or y equals 1. So when I plug in 5, I get 1. We've done 3, and this video is a little long, so I'm going to pause. We're going to just skip this D. We might come back to it sometime. It'd be great practice to do with a friend. But we're going to stop with those 3. That's a pretty good number of examples. And we got one more to go.